just coming here made me realize how much better an in-person conference still is. It doesn't even compare. So it's been really great being here again.
Hello everyone, good afternoon. My name is Diego, only Diego. And I'm going to talk today about a common package specification. I'm going basically to continue the plenary talk today. I'm doing this because I've been working in dependency and package manager for 10 years now, professionally. I am one of the Conan co-founders, and I've been working in Conan for now more than 7 years. And my goal is to bring here our experience doing package manager for C++ for so long. I'm going to start first trying to define the scope and what are we talking about when we are talking about a CPS. I will contribute to our implementation experience, and then I will quickly move to the actual specification. I will start with the basics, being guided with some real examples, setlib and OpenSSL, and then I will present some problems, some advanced use cases that requires attention, not always solutions, but at least I will expose the problems. And I will finalize with some adoption hints and my conclusions. So let's try first to define the scope of the problem that we are trying to solve with this specification. When we are building a C++ application like this one, and we want to use the functionality of setlib, we will have some code that looks like that. And we have to do a few things. First thing we need to do is we need to define the version of setlib that we want to use. Sorry, setlib 1 to 11 or 12, whatever. Then we have to define that we are going to do a build for Visual Studio, 64 bits, release, and we want to link setlib statically. And with that information, we will get somehow setlib in our system. We can use a system package manager, we can use a language package manager, or we can just build ourselves setlib manually. But we will finish with a binary compilation of setlib ready to be used. And then the goal is to pass the information from this compiled setlib to the build system. So in order the build system can use this information successfully to link my application together, so I have a working application. The scope of the CPS, of the Common Package Specification, is exactly this fourth point, how to pass the information from an existing package to the build system so the build system can use it. So when we are talking about a package, we are talking about this. We are talking about a compiled library, typically, or a set of libraries that is an independent unit of build and release. Okay. That means that you can typically put a version number on it. If you want to, it's not necessary, but typically you can put a version number. Okay? And of course, it's something that is ready to use. I don't care what build system was used to create this binary, as long as I have the binary package ready to be used. And the goal, the scope of the CPS is, okay, the build system needs to pass the compiler flags, like the include directories, the -i compiler flag, and others. So the question is, how can we provide the build system with enough information so it can do its job and pass the right compiler flags to the compiler? And this is exactly the scope of the CPS that I'm talking about. The CPS is a file that defines what a package contains, so this information can be used by any build system to produce a correct build. I'm not the first one, of course, as you know, to talk about this problem, and this morning we have had a very interesting plenary talk about the CPS. There was a preliminary work pioneered by Matthew Wolke, and there have been other interesting jobs, for example, the libman by Vector of Bull that also deserves attention. And I'm not going to explain further why existing solutions like pkg-config or CMake files are not perfect for the problem at hand. Okay, this is already enough literature and talks to know that they have some limitations, and we want the next step into this. Why I am also proposing this? Because René Rivera, for example, has also a very good paper describing all the different parts that connect the ecosystem of package management, the dependency resolution, the versions, the building of the package. Why am I focusing on the CPS in this case? First, because I think this is the easiest part to get consensus. Okay, the other are going to be challenging. Deciding on the versioning schemes or how a version graph, a dependency graph is resolved is a very challenging problem. I don't think it's easy to get consensus, but we can get consensus. And actually, I'm very happy because I've seen this morning that there are lots of alignment on how we see the CPS from different vendors or different developers, right? And if we achieve this consensus, it will deliver the most value for the community. It will deliver a huge value to the community because it will be the biggest contributor to interoperability. That means that it doesn't matter if it is open source, closed source, it's a vendor, it's a system package manager, language package manager. It will be able to connect together all the pieces. It's the basic glue that will allow the first step towards doing more and more. So during this talk, I will use some assumptions. Like, for example, I'm always talking, when I'm talking about a package, I'm always talking about a compiled binary that can have been built by any build system. With a package, for me, is built with one single configuration. And I already assume that this binary configuration is already valid for my build. I'm not going to check if that binary was compiled with a different architecture and it will not work. I will assume that it will work, given if I provide enough information to the build system, it will work. It is compatible. It is binary compatible. I don't need version information. I don't need ABI information. And I'm also going to focus on this talk on the usage part. We have the CPS, and we want some build system to use it. But in reality, the CPS is the glue between the generator and the consumer, because the CPS, as we have also seen this morning, is something that the build system itself can generate. So in order to other build systems, we'll understand the resultant binary package. Okay, so let's talk a little about the implementation experience, because when we are trying, and this is the final goal with this CPS initiative, is that we are able to standardize something. We are proposing this, the goal is to propose this to the committee and have a CPS that is an international standard. Okay, when we are talking about standardizing something, you know that implementation experience is critical for success. Otherwise, you know what happens when we don't have this implementation experience. So this is what we are going to provide here. Why? Because, for example, we have Conan Center that contains 1,500 different recipes for different versions, and we compile them for Windows, Linux, and Mac with approximately more than 100 different configurations. That means that we have more than 500,000 packages, binary packages in Conan Center already. Okay? And they are downloaded, they are used like millions of times every month. These packages, they have been created by the amazing, amazing job by the community. So, for example, this is the number of pull requests we get per year, and we can see that last year we already passed the 5,000 pull requests to Conan Center Index. And also, very importantly, is not only the view of the open source community, because most of the Conan users, they are not using Conan Center in production. They have their own servers, they are creating their own packages. So we have, in these 7 years, we have also learned all the different use cases, corner cases that the enterprises need in order to implement these things. So we are also bringing here the experience of the enterprise world. There is not just the open source. So hopefully we can provide some guidance of things that should be done and things that not. Edge cases that might be edge, but are also important cases for many, many enterprise users, both open source and closed source. And I'm sorry to say, but I will not always bring solutions. Part of my talk, I will present some problems that needs attention, but not necessarily a solution. Maybe some hints on where we want to go, but not a definitive approach or proposal for this. One of the reasons that we can contribute our implementation experience is because one of the design principles in Conan is that every Conan package should be usable by any build system. And we have been doing this for years. As we didn't have a CPS specification, what we did is we implemented what we call recipes, or a Python file that is called the Conan file.py, okay, which is a proxy of the CPS. And if we thumb on the Conan file, we will realize that there is a method there, we call it the package info method, that is basically a description of the contents of the package. Okay, and here we can see that, for example, this is the setlib package info method that is defining what is the name of the library that is going to be created, and that needs to be used by the consumer of the setlib package depending on different conditions. Okay? So this is our abstraction. This information here can be serialized. We can just dump the CPP structure, CPP info structure as JSON, And this results in JSON files. These JSON files are the ones that I'm going to show you here today. So the JSON files that I will present are basically, not exactly, but basically very close to the ones that can be generated today from Conan recipes. But this approach has limitations. Okay, it has taken us very far, but for example, it is a bit annoying because you have to repeat in the Conan file, you have to repeat some information that the build system already has. Okay, and users don't love it. For a small library like setlib, this is doable. But if we want to package something like boost, that is a large thing, then your package info method is going to be this big, and this is not the best, of course, it can be a bit tedious. And it's also Python. While Python is great, and many of us, we love it, we are aiming for something that is simpler, it's a bit more declarative. So can we do that better? And we think yes. And this is the reason we are proposing the CPS. So let's move to this CPS proposal. And let's start with the setlib library. So when we are building setlib, we will have something in our disk that is like this. We have an include folder with some headers. We'll have a lib folder with the static setlib library there. And this is the CPS file that we can use to represent such a package. There are several fields here. Remember, this CPS is just the CPS for this specific build of the setlib package, which is Windows, Visual Studio, static library. Why JSON? Really, I don't care. I'm willing to play donkey. And if we agree that the XML is the right format for it, I will buy it. I really don't care. I prefer to have any consensus and move on than just bike shedding over the format. So let's move to the first attribute in the CPS, the include directories one. This would be relatively easy, right? Okay, let's see it. So the include directories will typically map to the -i or -i system on the build system, on the compiler flag, right? Why, Diego? Why aren't you adding system include dirs in your specification? Because it's a different thing, right? Sometimes it's a -i, sometimes it's a -i system. And why aren't you specifying that? Because this is not something that is intrinsic to the package itself. This is something that the user of the package wants to decide. Some users, they will want to treat their dependencies as system because they don't want the warnings at all, typically. And some other users, they will want to try to treat the dependencies as their own. And if there are warnings, they want the warnings. So they prefer to have the -i, okay, and not system. So it really is a choice that the consumer developer and the consumer build system should be able to do. And as such, it's not something that we need to represent in the CPS itself. Why is it a list of folders? Because there is no need to artificially constrain what library authors want to do. If some library author, they want to have 2 include folders with their headers, why not? We know that we can pass several -i flags, right? So why artificially forcing them to have all their headers in a single place? There are other reasons, and we will see them later. It will be more clear why a list of folders is necessary. And finally, can we use any convention? Why specifying always the include? Hey, come on, this is just the default. If you don't specify it in the CPS, we can assume that they include. So why are you making it explicit? Because, hey, surprise, there are packages that don't contain headers at all. And there are build systems that if you pass them a default, whatever include folder that doesn't exist, they will error. Okay, so the golden rule here is always, it's like the Python sen, better explicit than implicit. Being always explicit is a JSON file. It will take 1 extra line, but it will avoid many problems. So I'm strongly in favor to be strongly explicit instead to try to define some defaults, some conventions over the defaults. Okay, and the other part about the include directories is that they are relative paths in general, because one interesting property of packages is the capability that we can relocate them. So if we have a package in disk, we should be able to do a move of this package to another location, and we should be able to consume this package in the new location, exactly the same as we did with the previous one, without really necessarily having to pre-process or change the CPA, recompute the CPS in any way. So if the paths are relative, we can just move and we can reuse the whole package with the CPS in the new location transparently without doing anything else. That doesn't mean that we should always enforce all paths to be relative, because we want to cover different use cases. And one use case would be, for example, the case of system packages. And if we have system packages, they do not necessarily share a common root in the file system. And we can represent a system package that could be in some standard directories in our system. In that case, it's necessary to have absolute paths. Yes, this specific system package, we cannot relocate it, we cannot move it. But the litmus test for this is, can this CPS file be generated as a result of a build and install process? Yes, it can. The install information knows where the artifacts are. Can I use this CPS in another build system to use these library successfully? If both responses are yes, then there is no need to artificially restrict or constrain the CPS to always enforce relative folders. Okay? It's a desired property, but not necessarily. So more fields in our CPS. Library directories and library names. This maps to -L uppercase and -L lowercase. Nothing special here. This is pretty straightforward. And then let's move to an interesting part, because this seems a bit advanced, but I wanted to include it in the very first example. Why? Because so far I've mapped the setlib package as setlib in lowercase. Okay? But the whole CMake ecosystem, they are depending on setlib as a config file, as a config CMake file in uppercase, and they also depend on setlib, : setlib in uppercase. Somewhere, this information should be somewhere if we want to have a transparent integration. Otherwise, we will be breaking the whole ecosystem. We cannot have a CPS file that cannot be mapped to existing code without breaking. And in this case, this mapping, we call them the properties. Properties are extensions that we can use for specific build systems to provide them more information, so we can have this CPS file to be used by these specific build systems without breaking the existing ecosystem. And I think this is a very necessary property for a CPS proposal to be successful. Introduce the less friction possible into the existing ecosystem. Okay, so far so good. Setlib was reasonable. Let's move to a more complicated example, which is OpenSSL. Because if we build OpenSSL and we inspect the package, the artifacts, we will see that now we have two compile libraries. We have the crypto library containing the cryptographic functions, checksums, hashes, and such. And we have another library, SSL library, that contains the protocol and that depends on the crypto library. So we have now two libraries. So if we have two libraries, what does linking OpenSSL mean? So for the majority of the users, it typically means, hey, I want to use the SSL protocol, so I want to link with the SSL library, which transitively it will link with libcrypto. Okay? Typically transparent for me. I don't even know that I'm linking libcrypto. Okay? But it's there. But there are real use cases that say, hey, OpenSSL is great, but I don't want the SSL protocol. I just want the cryptographic functions. So I want to be able to use just the crypto library there. But if I don't have a specification for this, the best a package specification could do for OpenSSL is inject both of them, -L SSL, -L crypto. Some linkers might be smart enough to optimize that away, but some other linkers are not. Especially special linkers for embedded proprietary, embedded cross-tool chains, and everything. They will not be smart enough, and they will just embed everything into the binary, creating larger binaries than necessary, specifically in those scenarios, embedded scenarios that we want small binaries. Okay? So then we need something. We need the CPS to correctly model these components so they can be used effectively, they can be linked effectively by consumers. So CPS for OpenSSL could look something like this. And we will have different components. In this case, we will have the SSL component, and we will have the crypto component. And every component will specify its own fields. Every component can have its own include directories, its own library names, and so on. Why not separating every single library into its own file. Well, this is just an implementation detail of the specification. Okay, this can be done, and in this case, for example, Liebman proposal suggests this, to have several JSON files, or several files in this case, with a common library specification. Okay, this is good as far as we don't consider OpenSSL, SSL, and crypto two different things. Because OpenSSL maintainers, they are not going to split their projects. They are going to provide a single unified build of both libraries, okay, with a single version on top of that. So splitting that is going to be impossible. So as long as the maintainers, they are not releasing it separately, we have one single package. And the view that we have of the build, of the release, of the image that we have of OpenSSL in our disk is that view. Okay? The entry point as such to consume OpenSSL should be the CPS. I'm totally fine if we implement the details of every component in a single file. It's just an implementation detail. But it's not possible to just split crypto and SSL into different packages that are completely different entities. An interesting thing that appears in the OpenSSL CPS is that the crypto component, it has dependencies on system libraries. In this case, if we want to link with crypto in Windows, we necessarily have to link with some system libraries. Okay? This can be specified, and this should be specified by the CPS. So the consumer that is linking with crypto, they don't need to figure out that they also need to link with crypt32, in this case, for example. But the most interesting part that these components bring is the requirement definition. Okay? We will have in the SSL component, we will have a requires definition that is pointing internally. It's pointing to another component inside the OpenSSL CPS, right? This is exactly the dependency between the library, the libSSL library, and the libcrypto library. But it happens that the libcrypto library, it has a transitive dependency to setlib. And we should be able to represent this relationship somehow. We are proposing here to use the setlib : notation to represent an external dependency to the package setlib, and then the second part setlib could be a component of setlib, or if it's setlib, is the whole setlib package. In this case, I'm expressing that the crypto component library depends on the whole setlib package, which in turn contains just one library. When we have transitive dependencies, okay, we have, let's say, an application that is linked in OpenSSL. Okay, this introduces a transitive dependency to setlib. Okay. And it happens that depending on how OpenSSL uses setlib, the transitive requirements to the final consumer applications will be different. Okay, let's take, for example, the headers. The setlib headers can be used by the public headers of OpenSSL. If this is the case, when we are building the application, we need the include directories of setlib in the final compilation. Otherwise, the build will fail, right? But if, on the other hand, it results that OpenSSL only includes the setlib headers in its implementation files, the headers of setlib can be hidden, can be completely hidden from the application. Okay? This is similar to the CMake private and public relationship, but the problem that we have seen is that there are more, this is not just a two-state case. There are more cases that needs to be represented. And they seem a bit crazy, but between two libraries, there can be cases that you don't actually want to link with the library. And we have seen that in production. Hey, I'm using this big library, which is not a header-only library. Okay, but for some reason, my code is only using some bits, some definitions, some templates that are in the headers. So please do not link with the static library. But I want the headers there. Okay, so this is a real use case that we have seen. And then there is a need. We might need to extend, we might need to qualify the requirements from one package to another with some, we call them traits. Okay, it's the equivalent to the public and private interface in CMake. But there might be some extra details that we might need to cover all the cases. Okay, this is something that requires probably a 1 hour session about it. Okay, I'm very happy if I just bring here the idea, and there is a need to provide more details in the requirements than just the name of the thing that you are requiring. Okay, what is very important is to try to have some consensus and we're not agreeing on what is a component. Okay, because so far, these components are okay. We can have this dependency graph. We can be creating this game, my game, that depends on the network package and the engine package. And the network package can have a dependency on OpenSSL on the SSL protocol. Okay, so it is specified that it requires the SSL component from OpenSSL. And in the engine package on the right side, or the right branch of the graph, it can say, no, I only depend on the crypto component of OpenSSL. Okay, so now we have this diamond structure, but if we expand the whole graph of libraries, we will see that we have a consistent dependency graph with all the libraries that can work perfectly together. But if we try to do this with components, this will be a problem. Say, hey, okay, yeah, we have components, so I'm going to use a static component for setlib, and I will put the static library here, and I will have a dynamic component for setlib, and I will put the dynamic library there. Okay, then someone creates the network package, it says, okay, I require setlib static, perfectly, you create the network package, it works. Someone creates the engine package, it says, hey, I require setlib dynamic, it compiles, it works, so far so good. And then when someone is trying to use those packages, then you are going to get at least link errors or ODR violations, whatever, because the dependency graph of libraries is not consistent at all. You are linking setlib in 2 different ways, and this is a problem. That doesn't mean that you cannot use different views. For example, in the case of Boost, you can perfectly introduce components, and you can depend on the Boost headers, and you can depend on a compiled library of Boost. As long as you introduce a consistent graph of libraries, then the components definition is perfectly okay. I think the static and dynamic was very evident, but maybe this case is not that evident. What happens with libraries, that they can be a header-only library, like spdlog, or they can be a compiled library. Okay? If we try to represent these 2 states, these 2 things, as components, we can have exactly the same problem as we had before. Okay, we can have a dependency graph that it will include spdlog in 2 different variants that are incompatible. You cannot use both of them at the same time in the same dependency graph. So what is a component? A component is a part of the package. It's a part of the package that can be optionally consumed or not. They shouldn't be mutually exclusive. You should be able to use all components in a package together. Okay? And they will typically have some interdependency. On the other hand, components shouldn't be different binary variants of the same thing. Okay, that's a different package. That's not a different component inside the same package. And components, they also don't try to be an optimization over the build or distribution. Components, hey, I want this component from an OpenSSL. That doesn't mean that you will only build OpenSSL with that component, because the OpenSSL build, no one wants to touch it. OpenSSL build will do this thing, it will build the 2 binaries, and this is going to be immutable. But at least you can decide which libraries are you linking. So what would be the right approach for the spdlog case? So instead of having a CPS that tries to wrap the two different variants of the binary for spdlog, you can perfectly, what you have is 2 builds of spdlog. You have one build that puts all the headers together for a header-only case, and you have another different build of spdlogs that is creating a static library. If you have 2 different builds, you have 2 different CPS files, one for every different build of spdlog. Okay, so far I've been touching just a few points of the CPS. I just wanted to say that the CPS can have lots of fields, lots of attributes. It's not necessary to go over all of them today. Okay, I think we have covered the most important ones, but there are cases, for example, like this. You have a library and it uses some preprocessor definitions in the headers. Yeah, so in order to use this library successfully, you need to apply those definitions in the consumer. So there is no need for the consumer to figure out they have to add these definitions in their build system. So we can define them in the CPS, and they will propagate automatically to the user of the package. The same happens with source packages. Is it possible to create packages that contain only sources? Okay, the most important point here is that we shouldn't confuse this with submodules. A source package doesn't contain any build system. It's intended for the sources to be directly used by the build system of the consumer. Because if we are wrapping that as build system, we are creating like our own implementation of submodules, basically, and we don't want that. We want the CPS to be like agnostic of the build system of the package. And something similar happens with the objects. It's not necessary to go over that. Okay, so those are basically the basics for libraries as popular as setlib and OpenSSL. Let's move a little bit further and some more advanced use cases, because for the library definition, we have seen that the library name, basically what you pass to the -L to link, is typically good enough 95% of the cases. Okay? But it happens that there are cases, for example, in CMake, there are users that they want to use the imported location properties to be able to gather the shared libraries that you are linking in your applications. Okay? And if we are using only the -L name, you don't have enough information. This will work both for static libraries and dynamic libraries. But there is some information missing there that can be used by CMake to represent the important location. Okay, so the way that we can solve that is we can append extra information to setlib. In this case, setlib, we can say, hey, this is a shared library, and this is the import library, and this is the shared library. And if we specify this information, many times we will not use it because -L setlib is good enough. But if we want to do some advanced uses like recollecting all the shared libraries, the information is there. And the build systems can leverage that to basically use the shared libraries they are linking. And now that we have opened the shared libraries topic, the runtime. This is something that we have also been neglecting because honestly, linking with the libraries is complicated enough already that we are not tackling the runtime problem at all. I think with the CPS is the right moment to also to open this conversation, because there are basically 3 different mechanisms to handle with runtime dependencies, with shared libraries. We have RPaths. We can copy the DLLs in Windows to the executable, or we can use environment variables. And all of them are problematic. Sometimes, hey, RPaths are perfect. They work perfectly okay. Okay, first, they do not work in all operating systems. And they work great, for example, for system dependencies. But for developer dependencies, let's say that you have your application built, you have OpenSSL built as a shared library, and now you want to switch. You want to use 2 different setlib shared libraries. You can do that. You can hot swap them because the APIs are fully compatible and so on. If you are using RPaths, you are forced to patch the binary of OpenSSL to point to one to the other. And this for the developer use case is less than great. And finally, if we also want to relocate artifacts, then the RPaths can also be a problem. The same happened with the DLL approach, copying the DLLs over in Windows. It only works in Windows. Okay, and then this is a limitation. So it looks like that following the environment definition, like kind of Python virtual environments, would be the most universal and the best approach. But this, is more a question than a solution. It's just, hey, we should be talking about this because this is a pain that we face every day, and we are not talking about this. So please, let's take that into account so we can add enough information to our CPS files so we can use them at runtime also successfully. What happened with conditionals? So the moment we have the CPS, we are tempted to do this. Because, hey, we have the setlib for release, and we have setlib_d for the debug build of setlib. And then we need to, how can we specify this in CPS? Okay, we could do something like this. This looks declarative, but it is not. This is a conditional. This is, hey, if you are doing a release build, use this library. If you're doing a debug build, use this other library. And conditionals are bad for this kind. If we are doing declarative, it should be really declarative. What would be the right approach to handle, to model this? So we have 2 different CPS. A CPS is a view of a package that we can use. And the release build is one thing that we can use, and the debug build is a different thing that we can use. Okay? Even is not common, but we have also seen libraries that the headers are generated and are different for debug and release. Okay? So in this case, having a CPS for release and having a different CPS for debug is what really makes sense. And one of the things that we have learned in the years is that it's even better if the package itself is different. If we don't put together the release and the debug artifacts, it has lots of benefits. The way this scales is much, much better because it's not only release and debug. Then you have to factor release with dev info, or some users, they have release with my special optimizations, and then if something is built in release with a static. So there are tons of combinations there that will not scale if we try to put all of them in the same package. But if we have one package for every configuration, this is an approach that really works well. And if we represent each one of them, which they're its own CPS file, then everything works. The same approach, the same reasoning should be applied also for user things, not just release or debug. But there are users that say, hey, I have a version of my library that is optimized, but isn't safe, and I have a slow version that is safe. I want to be able to use one or the other. This is also a conditional. We want to avoid it. Same use case for fat libraries. Fat libraries are the same library for two architectures that you build them with the two architectures and then you put them together. But those are actually two different builds that you put them together. Some of them might require to have different definitions, okay, for the headers to work properly. And this is a problem. So in general, our proposal here would be, we know that there are packages there that they have tons of conditionals over the information. In Conan Center, we can check and we will see that there are tons of them. Most of them are for tools, tool chains, tool requires, okay? But we strongly believe that for libraries, which is the first problem that we want to solve, but for libraries, it can be avoided mostly. So the aim here would be, let's avoid conditionals in the CPS files completely, okay? And let's focus on, we have one package that means one binary configuration, and it means one CPS. And this is the approach that can really scale. Next advanced use case. Something really important. This is important, very important for the enterprise, for example. When we are defining this and we are working in OpenSSL and setlib, let's say that we are building OpenSSL, okay, and we are linking setlib. But eventually someone, I'm also modifying setlib code, and I'm building it. And in this case, in order for OpenSSL to use setlib, we need the package form of setlib, right? That means that every build I do on setlib, I should do an extra package step that copy the artifacts from the build view of setlib to the package view of setlib. Sorry, my screen has gone dark, that one. Thank you. This for setlib is pretty cheap. But if we are doing the same for Boost, for example, that means copying a lot of artifacts from the build view to the package view. And that can introduce like some delay that will be annoying for developers. The good thing, the good news, is that we can use the same concept of Python with editable packages. We have the CPS specification. And as long as it is powerful enough, and it can be also used to use the packages, to use the binaries directly from the build view of setlib. In this case, we can point our OpenSSL build to the setlib build just by defining the right CPS. And we can see here the example. And now we understand why it is so important to have include directories as a list of things. Because in a build view, it's very typical that you will have more than one include directory to work. Also more than one library directory. Yeah, maybe your library directory is not going to be the beautiful lib directory that is common exists in your package view. And you will have to specify, hey, this is the release 64 folder. But as long as you specify that, you can link perfectly the artifacts in the build view of setlib. Okay, and finally, one of the most complex scenarios here, but I strongly believe this is also a great opportunity to handle this problem with the right approach. Let's take the example of protobuf. Okay, protobuf is a library, okay, mostly. And we can have the find package, we already know how to build a CPS for protobuf library. Okay, but if we check a typical project using protobuf, we will see that it's also using some functions or some macros, like protobuf generates CPP, something like that. Where are these functions? If we check the build, the protobuf package, we will see that there is the config CMake file inside of this is defining these functions or macros or including them, but they are part of the package, okay? And what is more important, these config CMake functions, they have a fine program proto-C because they are basically using the proto-C executable to generate code. They are calling proto-C to do something, okay? And this is something that is super useful. It works great. And it's also something that we can represent in CPS. Okay, the CPS, we no longer need the config CMake, but we can perfectly add our proto utils, for example, .cmake in our package. We can add them to the CMake modulus property, and then this can be perfectly used by the CMake build system, so your CMake list will keep working as they have been working. But there is only one problem here, okay, which is the cross-compilation, the cross-building scenario. Let's say that we are building an application that is going to run on Linux. Okay, so on the right side, we have the host context, which is Linux. Okay, the machine where my application is going to run. Okay, we call that the host context. So in this case, my application will have to link with the protobuf lib that is compiling the package with Linux, ARMv8, GCC 5. Okay? But if for some reason I try to use the proto-C executable that is inside that package, it will fail because I'm cross-building from Windows to Linux. I'm running my build on a Windows machine. Okay? So obviously, if I try to execute the proto-C executable from the Linux package, it's going to fail. Okay? So what I really need for my cross-build scenario, I need another package for protobuf, which is the Windows package. Okay? This Windows package will contain the proto-C that we want to use, okay, which is the Windows executable. Okay? This means, and of course this executable will be a Windows 64 bits, probably built with MSVC or whatever. That means that we have two different packages, two different binaries with different artifacts. Okay, one for Windows and the other for Linux. And that means that we have two protobuf.cps files there. And now what should the build do? We need the build system to take the include directories, library directories, and libraries to link with from the host context. And when it's calling the proto-C, whenever we need the proto-C, actually when we are going to use the macros of the protoutils.cmake to generate C++ code, we need the build system to locate the protoutils CMake in the Windows package, because that will be finding the proto-C in Windows, and they will be able to run the proto-C of the build context, which is the Windows machine. Okay, this is something that Conan has been doing for a long time, as it's typically challenging to do, because it's a kind of a new concept that you need actually two different binaries of the same thing if you want to cross-build. Every time you have an executable that is connected to the libraries of the same package, you have this scenario in cross-building. And this is something that the CPS should be able to represent. Okay, so far we have been talking about CPS files, but where are those CPS and how my build system is going to use those CPS files? This morning we have seen that the initial implementation, the initial proposal for the CPS proposal is proposing a search order, a priority, and the CPS files should be looked here and there and there and there in this specific order. I say, in my view, this is probably one of the biggest points of using config CMake files in cross-building scenarios and in embedded scenarios, because we have, and especially when we are managing like a polyglot with different package managers, we have users that they basically want this scenario. We have a sysroot, and we have some packages that we want them from the sysroot. We have some packages that they are in our Yocto build, and we want to use these packages from the Yocto build. And finally, we have some other packages that are Conan packages, and we want to specify these other packages. It happens that it becomes super challenging or sometimes impossible to have a combination of CMake variables that will define the right priority for all these different libraries to locate them in the different locations. Okay? So our proposal here is something like this. Let's say that we have our CMake list, and we have our find package OpenSSL, and we have find package setlib. So we basically need OpenSSL and setlib. We use whatever tool or we build them ourselves, and we have our binaries in our disk, okay? And we also have our CPS files there together with our binaries in our disk. So our proposal here is, okay, if you don't specify anything, search path is perfect. It makes our lives easier. I'm not advocating against that. It's super useful. But let's please use a mapping, a explicit mapping, so that allows developers and tools to decide which CPS should be used. In this case, it could be something like this. And it can be something that is even the developer can explicitly write this file if they want to. It's just a mapping. Hey, setlib will be this instance here, and OpenSSL will be this other instance here. Because if we have this mapping, this allows us to cover all the advanced scenarios that we have seen today. Okay. Let's say that we have the cross-compilation scenario that we have seen with protobuf. And we also have custom configurations that the users are defining, not only release, but we have release DLL and debug static configurations that the users are customly defined. This can be perfectly represented by a mapping that we say, hey, all the host dependencies will be this setlib, OpenSSL, protobuf. Okay? For setlib, for the release DLL configuration, you can find the CPS here. For the debug static configuration, we will find the CPS, the build of setlib here. OpenSSL, I want to use the OpenSSL from the system. Okay, so then I can, for every configuration, I don't care which one I'm always going to use the same OpenSSL in the system with the CPS is in this exact path. Okay, for protobuf, I will again use release DLL and debug static, specifying the location of the binaries. In this case, the host context is the Linux context. Okay, and then finally, I can also specify the build context. I can specify a protobuf in the build context for any configuration because I really don't care. I just want to run protoc. So I don't care if for the release DLL or the debug static, the protoc executables will be exactly the same one. So for every configuration, I want to use the protoc that can be located in this CPS in this location. Okay? So this mapping, basically this explicit mapping provided to the build system is what can implement all the use cases that we have seen before, and this will be like a new experience. It will solve a new set of problems that we have been suffering so far in a great way. Okay, to finalize, I would like to give some adoption hints, some idea that probably will help with the adoption of this proposal. Because we have seen that we have both the generation of the CPS and the consumption of the CPS. The generation is going to be easy. If CMake is doing that, then it's going to be amazing. But there will be other build systems that they are still very used, like Make or Bazel, that they are probably not going to buy in that quickly. But we want their dependencies because there are very interesting libraries there that we want to use them as soon as possible. So we want the CPS files for them. How are we going to achieve that? Can we probably use, I don't know, some scripts, some templates that we can contribute to the projects so that the build of those projects, we can generate the CPS in an easy way? Are those Bash scripts, Python scripts? Maybe we can create some introspection tool that will just inspect the folders of the binaries. Say, okay, there are headers here, maybe include theirs, and it can deduce the actual CPS for many cases. Or are we just relying on the community to contribute the CPS in a custom way for every project? This is a conversation that we need to have. Okay, otherwise it can be like, the adoption will take more time, and I think we want to be this as quick as possible. And then for the generation use case, that is easier. In this case, if CMake is going to understand the CPS natively, that's amazing, it's not a big deal. What we have been doing so far is from the CPS, we have been generating config CMake files. The moment you have enough information in the CPS, creating your own setlib config CMake is doable. You have the information there. Okay, so you can do it. There could be some discussion about the properties, for example, in this case. Is this really a responsibility of the CPS? Or this is something that the mapping from the CPS to config CMake files should contain? So we could discuss more or less the borders of this information, where we want to put each thing. Okay, but this is doable. So for CMake, it sounds it won't be a problem. But what happened with other popular build systems? So actually, for example, Visual Studio, we are already doing that in Conan. You take the CPS, you generate properties files, and then you load the properties files with the ID, and it works pretty well. So the moment we agree on one CPS, creating this tooling for Visual Studio users, then it can be done in a couple of days. This is amazing. And I think having these tools will really improve the adoption speed of the CPS. Okay, and finally, some conclusions and next steps. Question that you might have, what about models? Diego, you haven't talked about models. I think there have been like fantastic talks of Andreas and Luis in this conference. Models, there has been amazing progress there, but there needs still some needs. I'm focused here on we have an ecosystem of libraries with headers. It's going to stay here for years. I don't want to wait years. I want all these existing libraries with headers to be usable in 1 year or 2 years with the CPS, so we can have this interoperability with build systems as soon as possible. When models come, we will also keep working on standardizing that and making sure that the CPS can also represent model libraries with models. Okay, but there is still some work to do in the models implementation and so on. Also, you can ask, hey, Diego, you have been focused only on include directories and things like that, but a CPS can contain many other information. And the answer is yes. I've been focused on the build information of the CPS. The CPS can contain actually information about the binary itself. It can contain if it is is linking with the dynamic runtime of the system or static system, the glibc. There are tons of information that we can add there to my package that we can use for new checks, new use cases, checking the binary compatibility, and that can avoid many of the errors that we have seen this morning. Okay, and we can also have metadata that can be very useful for SBOM generator, for example, SBOM generation. Okay. I'm focusing on the build because I think our MVP, we should be as lean as possible, and we should focus on an MVP as soon as possible. That brings our experience, and we have tons of experience from CMake and pkg-config of the information that we need to build system to build. We really don't have that much experience with the ABI information. We really don't. Okay, but this is something that we should focus, and this should be the priority in our point of view. So our next steps in this, we have been super busy with the launch of the Conan 2.0. But we are finally stabilizing that, and we are finally seeing that we will get enough time, enough bandwidth to put effort on this. So we are resuming work, and this talk is the proof that we are finally having some extra time. So we will make this a priority again because we think this is also a priority for the whole C++ ecosystem. So even if Conan is solving the problem quite well, we think it's better to think like widely for the wide benefit of the community. And if we are able to interoperate also between package managers and VC Package and Conan, this will be better for the whole C++ ecosystem. So we're going to put some efforts with this. We plan to collaborate with Bill and Brett and CPS. So everything that I've seen here is not planned to stay here. I plan to start doing pull requests to the CPS specification. We need to talk about that and to see how we are going to work and collaborate, because the idea is to converge, to fully converge, and to bring a common proposal for the ISO committee. And on our side, we will keep on our implementation. Anything that we start to agree, any consensus and everything, we will implement this in Conan. We will start using especially CPS files in Conan packages as well. So we will move from the package info to the CPS implementation as soon as possible. As soon as we start to do some progress, we will provide the implementation experience as soon as possible. And that's all from my side. Thank you very much for your attention. We will be tomorrow in the booth. Also, if you want a T-shirt like this, you will be very welcome to get yours in the booth. And thank you very much. And any question?
Yeah, actually, I have two questions, but I'll try to keep it short. So you mentioned that for one package different configuration, we want to have CPS file per configuration.
Yep.
How would you find those? Because like there are all these search paths. How would you find the zlib one config versus the other config?
Okay, so sorry, yeah, this is a good question. How do we find different CPS for different configurations?
Yes.
Okay, so yeah, exactly. We need to basically understand what the different configuration means. And a very common use case is release and debug. Okay, so basically when we do a release build, we will put this in a release folder somewhere. And when we do a debug build, we will put the result in a debug folder. And then the mapping is the file that defines, when you are building in release, you want to use this build of setlib, which is found in the debug folder or in the release folder. Okay, this can be a set of conventions that we want to use. This morning we have seen the add release or add debug convention that we can instead of being a folder is in the name of the file. I really don't care. It's just a convention that says, hey, when you are looking for release binaries, this is the CPS for the release and this is the CPS for the debug use case. So we can use folders as conventions. We can use file names as conventions. And finally, my proposal here is to be fully explicit, to have at least a layer that we can specify exactly what you want for the configuration that you want. And if we have tooling that can automatically generate this mapping here, perfect. But at least have the explicit mapping for the different configurations.
I see, thank you. And the other question about interoperability between the build systems. So it was not really clear to me whose responsibility is it to generate a CPS file. If it comes with a library, I can understand, okay, I can then build this library in this build system or the other build system, CMake or Basil or something. Now, if it's the build system that generates the CPS file, then what's the point of interoperability? I already have, all the CPS files generated by CMake. So how would what would be my incentive to use them in Basil?
Oh, sorry.
I hope it makes sense.
Yeah. So it's basically this. Yeah. So from our point of view, the responsible of creating the CPS is the build system of the package. So if we have setlib in this case, and setlib is built with CMake, then you call CMake install, and what you should get is the setlib binaries, and you should get a CPS file together with your setlib package, the headers and the binaries, that represents what you just built. Okay? The purpose of this is what Bill was saying this morning, is, okay, we have the config file. In a CMake-only world, it works well, but we want this setlib package built with CMake. We want to be able to use it transparently in CMake, or in Meson, or in Visual Studio, without using CMake at all. Okay, and the only way to achieve this is if the creator of the setlib package, in this case CMake, is creating this CPS file, then any other user of setlib can use setlib successfully without depending on CMake. And this is the goal.
I see, thank you.
You're welcome.
Yep, thanks for the talk, really exciting stuff. Circling back again to the multiple configurations in a package, and like you mentioned that like conditionals are bad, without really going into too much details why they're bad, and that, like, to me that's a bit surprising, right? In particular, if I think like I'm working on a multi-config generator, right? Then if you only give me the debug or only give me the release, it's only half the package, right? In those environments, I always want both. So I was wondering, like, what in particular are your concerns? What causes you to say that it's a bad pattern to have these conditionals in the package?
Okay, there are several concerns about scalability when you are talking about configurations. So because we have this, okay, most scenarios are release and debug. So let's say that you can create a package that contains both release and debug artifacts. And then you have a new user or a new team in your company to say, hey, we also need the rel with dev info packages. What are you going to do with that? Because also there is a principle in DevOps for all languages and all package managers, is that packages should be immutable. Once you have a build of setlib in this case, you shouldn't be modifying that package at all. Rebuilding it is a mistake. Changing the files inside a package is a mistake. It breaks all the traceability of your DevOps pipeline, for example, and your SBOMs and everything. So what do? You cannot just do a rel with devinfo binary and put it inside of the binary of the existing package. So for a basic world when we only have debug and release, it's fine. But for any scalability that we have different variants that might evolve over time as well, okay, it really doesn't work. So this is something, and the answer is for developers and IDEs with multi-configuration, we can still make it work, and we make it common. You do, basically, you get the release binaries, you get the debug binaries, you have two CPS, and you put them together to your build system, and then you can still swap in the IDE from debug to release. Just you are not using the binary from one single location. You have one location for the debug and the other location for the release. But it's doable.
So if I understood you correctly, like the goal here should be that the individual packages with the individual configurations, they should be self-contained, but they should be composable amongst each other, right? So that I can always take the debug and the release and have both of them, like pull both of them in if I'm in such a multi-config.
Once you have the CPS, you don't need to merge the binaries at all. You can have them in different locations because as long as you have the location of the CPS and the relative paths to the artifacts there, and the location of the other CPS, the release CPS, and the location of the artifacts, then you can merge in the build system. You don't need to physically merge the artifacts in order to use that.
Yeah, I think I got it now. Thank you. Yeah.
Okay. Well, you're welcome.
Hi. Thanks for working on this. I have two questions. I'm sorry. First one is, at the moment, if you maintain an open source library, right? You have a Conan package, you have a VC, like Conan package recipe, you have VC package, I don't remember what. There's a Spark JSON, there is also instructions how you git pull the thing. Right, so the question is, in a CPS future, what do you expect the library to have actually in terms of like, okay, I am a consumable library, this is what I have?
This is a very good question. The goal of this proposal is a library author should typically only be focused on generating good CPS files. But because the moment you have the CPS file, it's like distributions, like Linux distributions. You are not concerned about creating the Debian package for your library. The maintainers of the Debian package, they will do it for you. Your goal is to make your library as packageable as possible. And if you are creating CPS, basically the Conan recipe to package your library is going to be like this. And the VC package port to package your library is going to be super simple. And the spec, whatever. And this can be contributed by anyone in the Conan ecosystem that they want your library. They can contribute the recipe in 1 hour. As long as your library is easy to build and it creates the correct CPS for the different binary configuration that you can create, then the job of the package maintainer is going to be super easy. So that shouldn't be your responsibility, but from the community of the ecosystem.
So kind of like to clarify, a CPS file at the root of the library generated from CMake or something.
Typically I would expect that. It can be in a subfolder. As I said, as long as you have a way to look for the CPS in your file system, in your folder structure, as long as there are conventions there, it doesn't need to be in the root. Probably if it is in the root, it makes life easier for everyone. But the location of the CPS, as long as it goes together with your binaries, doesn't really matter.
Like I'm confused. I have C++ files on GitHub. Where do I put CPS? Right.
Sorry, what?
I have some C++ files on GitHub. Like you can grab those, and I think you could use them and get something useful. Where do I put CPS in there? Like how? I generated I use CMake. I generate the CPS and I put it in the root.
No, you don't put it. It's a site. It's the same as the setlib static library. You don't put the setlib static library in your repo. When you're building your project, when someone is building your project, okay, it will generate the setlib static library, and it will also generate the CPS as a result of the build. But the CPS is not in your repo at all. The CPS is part of the binary. It's not part of the source code. It's not the source code origin. It's something that describes the binary that your library generates.
It'd be like part of the install step.
It's part of the install step, mostly. Yeah.
Okay. So, like, if I want you to build, like, include in your directory, like, take my sources, include in your directory somewhere, against third party.
No, we are not taking your sources. We are only taking your binaries. So the goal of the CPS is to decouple. I'm not concerned about your sources. I don't want to know how your sources are built. I want to get your compiled library and have a CPS file that allows me to use your compiled library easily. Your library could have been built with CMake or Method or whatever other build system. I want something that decouples the way you build your library from the way I consume your library.
But, like, I need your flags to come. I need debug and march and whatever, and all the macros that you have to pass me, right, in order to get the correct result.
But we have seen that if there are macros that I need to pass, you can specify those macros as well in the CPS file. That's one of the goals of the CPS file. That if I need to,
if the CPS file is built, you can't do that.
But exactly.
So no, like, if I pre-build and then you, I think I don't understand. Okay, I'm sorry.
Different libraries on Conan with all the different configurations.
Because that would be a lot.
Okay. Thank you.
Hi, thank you for the great talk. I'm really looking forward to that. So one of the problem I run into recently is that in our project we use spdlog A, and we link to a static library that use a different version of spdlog. So I wonder if CBS can resolve that kind of problem, or it's depending on like CMake, how you link your library.
Sorry, I didn't get your question. Could you?
So technically, like, the library that I linked to, they use a different version of the library that I'm using in my project.
Yeah, exactly. That's a very good question, and this is something that is outside of the scope of this proposal, because that's basically the dependency resolution, which a dependency manager or a package manager does. It needs to reconcile all the different versions in the upstream. So there are mechanisms in the dependency resolution that say, hey, if someone is depending on this version and someone else is depending on another version, that is a version conflict. You need to resolve that. You need to decide which version you want to use. And if you are using a different version of the you might need to rebuild the binaries. So one specific package binary, when you force a new dependency upstream, might not be compatible. That means that you should build a new binary for the new dependency version, and this will result in a new build with a new CPS, probably. You might even need to bump the version of the consumer. It depends on the compatibility of the new version. So all that part of dealing with different versions of the different packages is part of a dependency resolver, package manager, dependency manager. That is it's a huge topic that we could also be talking for hours, and it's explicitly outside of this scope. We assume that the versions here are already consistent. If you are using spdlog, we are assuming that you are using the same version of spdlog in this proposal.
Okay, just a follow-up question. So like in the CBS file, when you use a library, will you be able to specify the version of the library that you want to use?
No, not in the CPS file. So the CPS file, you already took spdlog, whatever version, or setlib 1 to 13. You downloaded that tag from GitHub, for example. You build that thing. You have the setlib static library. That is already the package for setlib 1 to 13. And then you don't need the CPS file for that to include the version information. It's already what you want. What you want is to pass the information of that build of setlib 1 to 13 to your current build. So it's several steps process. So resolving the version is something that typically needs to happen before you are able to use the binary into your application. And also the scope of the CPS is you have already decided the version. It's already given for you. and you have downloaded it, and you have built the thing, and you just want to use that thing, whatever version you decided in the past, you want to use that thing in your build. So yeah, defining the version here is outside of the scope because it's a much different problem.
Thank you.
Yeah.
I do think it would add, the information would be there to add extra information to tools like CMake, CPS is around it, then we could detect
Yeah.
things like that.
Absolutely. So I'm not saying that the goal of the CPS should not cover like version information. In this case, having the version information here for setlib itself, or having version information of possible dependencies of setlib could be super useful to detect those things. What I'm trying to focus on, and the scope of this talk is let's focus on this part because we already know the answers as this morning. This is not rocket science. This is just JSON. We know how to do this. While managing the versions of yourself and the dependencies, that is a big problem. That is not really fully solved. Versioning, nobody agrees on the versioning scheme. The December specification doesn't even define version ranges. Every package manager out there defines its own version ranges expressions. Okay, so there is no consensus about version resolution, and specifically those other package managers for dynamic languages that they don't need to link and compile. What does versions mean in the C++? We need years to have some consensus on that. So yeah, having versions there, I'm totally in favor, but I think we should, at this moment, for the next 1 or 2 years, we should be strictly focusing on that because this will deliver huge value and we can do it, especially because we can do it. Okay, thank you very much.